All right, I did want to go ahead and go over one directly from MyMathLab because sometimes we have a hard time going from the videos that I do to the ones on MyMathLab, so I definitely wanted to go over one of these. So here we go. It says construct a 99% confidence interval for the population mean. Assume the population has a normal distribution. A group of 19 randomly selected employees has a mean age of 22.4 years with a standard deviation of 3.8 years. Round to the nearest tenth. All right, let's go ahead and get our distribution going. So first thing that I'm going to go ahead and identify is what is our point estimate. And what we are anticipating and what we're going to go ahead and center our confidence interval around is where our sample was. We have a sample mean of 22.4 years, and that is what we are going to build our confidence interval around. All right, let's take a look here. So 99%, we want to be really, really confident here. 99% is a pretty high confidence level. All right, so we have 99%. Let's discuss what we got going on for our tails here. So if we have 99% in the middle, that means that I have a 0.5% for each of my tails. All right, now do not forget if we are dealing with a mean, we are not talking about a normal distribution. We are talking about a t distribution. Mean t, Mr. T is mean. So what I need to do is figure out our degrees of freedom. So let's look here at, oh, hello. Didn't mean to do that. For our degrees of freedom here, it does say that we had a sample of 19 students. So if I had a sample of 19, my degrees of freedom would be 18. All right, and I need to do my inverse CDF to figure out that critical t-score. I have, oh, I forgot to name my distribution. I'll go ahead and name it A. So inverse CDF of A, my tail was a 0.5%, so 0.005. All right, and then for my critical value, my critical t-score, that is negative 2.88. So negative 2.88. So negative 2.88 standard deviations below. All right, so that should be enough information to start our calculations. So here we go. All right, so we centered this around 22.4. I need to subtract 2.88 standard deviations. And for our standard deviation of our sample, our standard deviation was 3.8 years. But I need to divide that by the square root of my sample size, the square root of my sample size. My sample size was 19. And if I type that into a calculator, we should get our left endpoint. So let's go ahead and try that. I have 22.4 minus 2.88 times 3.8 divided by the square root of 19. And my left endpoint for my low age is 19.89. 19.89. All right, 19.89. Now, looking at this, the only one that it looks like it's close to is C. One thing that I am going to check though, just to double check to make sure that this is correct, I am going to go ahead and make sure that my other endpoint is 24.9. Real quick, 24.9. Yep, and that's what I got, 24.9. So the answer to this one would be C. We are 99% confident that the mean age of this employer is somewhere in between 19.9 years and 24.9 years. All right, hope that helps.